Hello students, in today's video we will study about spherical mirrors. In the last video we studied about spherical mirrors and we studied about concave mirror. In a concave mirror the reflecting surface is inwards. The reflecting surface is inwards, the light has to go in. And I said that the middle point of this mirror is pole of the mirror and it is part of a sphere. So this is the center of curvature, and the line joining the pole of the mirror with the center of curvature, you called it as radius of curvature. Now I said that this line is the most important line because it is a line which is connecting the pole and the center of curvature. So a ray which is passing through the center of curvature and striking at the pole will rebound back in the same line. Now if I take a ray of light parallel to the principal axis, what will happen? This ray will obey the law of reflection. Angle of incidence is equal to angle of reflection. Right, and I imagine to be a plane mirror here, fine, and I draw a normal. The normal is nothing but the radius which is going to touch the center of curvature. So when I draw the focus, I will find that the focus will be passing through a point like this on the principal axis. So what is the focus? Focus is where all the rays parallel to the principal axis come and converge, they all come and meet, right? And that is called concave mirror. Concave mirror. Remember, mirror is an opaque object, and so you'll find that the light cannot pass through it, it is reflecting back. Reflecting is bouncing. One of the simple examples you can see, the dish antenna which you have at your homes, Tata Sky or whatever it is, they are all like concave mirrors only. The radio waves are coming and striking, right? The radio wave signals are coming and striking, and what happened? They all will get focused, and you'll find the transponder is fixed to here or the receiver is fixed to here, and so we receive. So where is the receiver kept here? It is at the focus. Right. So all the waves are absorbed at that particular point. They have been focused at the point, and that is what is happening in this case. And another application of concave mirror is dentists. Dentists, they wanted to check our teeth, and one of the tooth is very having some problem, then they will wear the concave mirror so that it will give you enlarged image which you will see in the further cases. Right, and in today's class we will study about convex mirror. That is the second other type of mirror which we are going to learn. Now, let me take the next type of mirror. In this type of mirror, again, a mirror is a part of a sphere. Now, I take this point here, this is the center point, fine, and I keep this point and I draw an arc. If I continue this, it will become a sphere. Okay, so it is part of the sphere. I am not considering the whole sphere. I am talking only part of it. Fine. So now I have drawn that. Now let me take here this part. Now which is the reflecting surface? It is bulged outward. It is curved outward. So I coat it inward like this. So this part is the reflecting surface. Okay, now as usual, this is the center of curvature, and that is the middle point. So this is pole of the mirror. I join with a line passing through from the pole through the center of curvature like this. But remember, reflection is taking place in this side. So object has to be placed this side. So let me extrapolate it, extend it backward like this in order to keep the object. So this line is called principal axis because it is connecting the center of curvature with the pole, and this is called principal axis. I hope you understand this point now. Now, as usual, center of curvature is here. I can measure the equal distance, and I measure the equal distance, and this point will become center of curvature. Remember, all these are imaginary. They are all imaginary because it is main part is that side, but I am taking it in this side. Now what will happen if you take this case? The ray which is passing through the principal axis will bounce back. That law will hold good. Now I am going to take a ray parallel to the principal axis. Right. Let me take a ray parallel to the principal axis. Right. This ray which is parallel to the principal axis. Now look here. This is the tangent. Right. It is like a plane mirror. Now when this is a plane mirror, and where is the normal? I said to you previously, normal at this point will join with the center of curvature. So I am going to draw the normal, and it is going to the center of curvature. And this is nothing but the radius. Everywhere this point is nothing but the radius or radius of curvature. And this is center of curvature. Fine. So the ray will go like this. It will diverge. This ray will diverge. It will not converge. It will, this is the center point I have taken. Okay. So in order to draw more precisely, let me erase this point. And this is the point I have taken. Fine. And this is the angle of incidence. Angle of incidence is equal to angle of reflection. It holds good for even spherical mirrors. So take it at this angle and you will diverge it like this. Yeah, the ray is diverging. Okay, this is the diverging ray. Let me take another ray parallel to the principal axis. Fine. Another ray parallel to the principal axis. Now look at it again. See, draw a tangent. Fine. Now as usual, draw a normal at the point of incident, which is touching the center of curvature. Fine. Now let me extend it further. This is angle of incident. The angle between the incident ray and the normal is called angle of incident. Now what's going to happen? Now this ray is going to again diverge. It is going to come in this way, and this is diverged here. This is angle of reflection. Okay, now it has diverged. There it is converged. And in a convex mirror, this mirror, which is a convex mirror, it is a diverging mirror. That is a converging mirror. But where is the focus? Will these two rays meet anywhere? No, they cannot meet anywhere. They are diverging. Okay. So what I do, mathematically, I extend it backward like this and touch the principal axis. And similarly, I extend it backward like this, right? And I touch that. And this point is called focus. What is this point called? Focus. Are you understanding what I'm saying? Right? So this is behind the mirror. Behind the mirror. The mirror is opaque. How can something be behind the mirror? So it is virtual focus. This focus is called virtual. Virtual means imaginary. It is a mathematical concept for our understanding. Okay. So the distance between focus and the pole of the mirror is called focal length. This is called focal length. F is equal to focal length, or we can also, let me write it here, focal length. So the words which you have to be very clear are these basics. You have to understand very clearly. The rays are coming parallel to the principal axis. Principal axis is the main axis with reference to which we talk. Center of curvature, it is center of the sphere from which the mirror has been made. Radius of curvature, the radius from pole to the center of curvature. Where the rays come and meet or appears to meet, right? Virtual. And that is called focal length, and focus is the point. And these are the basic things which you have to learn. In the case of a concave mirror, it is real focus, and in convex mirror, it is virtual focus. Let me tell you one application. Where do you use this mirror? In car rear view mirror, in bike rear view mirror, back what you see, all these mirrors are convex mirrors. Why? Because an object is coming from here, okay? So what will happen? The field of view, you see, the field of view, I can see more amount of what you call object coming from back. A larger field of view it is having, that's why I use it. We don't use a plane mirror. Where do we use the plane mirror? In the barber shop. You have a plane mirror and back there is a plane mirror. I see here, I see my image there. So multiple images are being formed. Multiple reflections take place. So this is how we use mirrors, and with this we learned the introduction of concave mirror, convex mirror, and the basic idea. Next videos we will see how to form an image formation. Thank you so much.